So the purpose of this video is to look again at how we can find the error interval after a number has been rounded. But to start with, we're going to go quickly over the difference between rounding and truncating. So first of all, rounding. If you wanted to round 32.34 to one decimal place, then you're going to have to identify which is this decimal place, which is the 3 after the dot. And this number, if you round it, it's either going to be 32.3 or 32.4. It depends if you're going to round up or down. And because it's followed by a 4, anything that's followed by 0, 1, 2, 3 or 4, you're going to round down. So the answer is not going to be 32.4, it's going to be 32.3. If you are going to now round 32.38 to one decimal place, so same idea, you find your first decimal place, and then this means that here it is a 3, so when we round the number 32.38, we could have either 32.3 or, if we round up, 32.4. To decide whether we round down or up, we look at the next decimal place, or the second decimal place, which here is an 8. And if it's 5, 6, 7, 8 or 9, we're going to round up. So this means that out of 32.3, 32.4, the answer, if you round, will be 32.4. So here the correct answer will be 32.4, because this is the one where we are rounding up. So what is truncating? Something that's been added to the GCSE content in the latest version of the current GCSE. Truncating means you will always, so here I should add to one decimal place. So truncating, you always round down. So you find your first decimal place and you're going to round afterwards. You don't need to worry about what follows this 3, you always round down. So if you have 32.3 whatever, you will have 32.3. So 32.34 rounds to 32.3. 32.38 rounds to, well, same again, 32.3. And this is how truncating works. So actually quite straightforward. So we are now going to look at the idea of error intervals. So let's say that we have a number, I've called it A, which is 47,000, but you've been told that actually this number has been rounded to 2 significant figures. So does it mean that your number was 47,000 to start with? It might have been, but maybe not. It could have been a bit bigger, it could have been a bit smaller, and we decided to round it, maybe because it made the number more readable. But what is important is to be able to understand, by doing this rounding and making the number more readable, we've lost a bit of information, we have caused an error. And it's important to be able to identify the size of the error. And this is what we're doing when we're looking for the error interval. How I would like you to do this work of finding the error interval, we're going to help ourselves with a number line. So first of all, we're going to look at having a number line, and on this number line, we're going to place the number 47,000. Now, if we have rounded to 2 significant figures, this means that on your number line, you would only have numbers that have 2 significant figures, which means that the number before 47,000 would be the first number before, which has 2 significant figures, and that would be 46,000. And the number after 47,000 would therefore be 48,000. The next stage is to have a look at what point would we have started to round towards 47,000, and at what point would we have tilted to 48,000. So there are 2 places that are quite significant, which are right between 46,000 and 47,000, right in the middle. And this point obviously will be 46,500 and 47,500. So any number that was between 46,500 and 47,500 would have rounded to 47,000? Well, every number almost, because if we had 47,000, I'm forgetting a zero here, 47,500 would actually round up, but 47,499 would round to 47,000. Yes, but is that the biggest number that would round to 47,000? No, because 47,499.9 would also round to 47,000. And so on. So we could keep on adding nines. All of it, they will always round to 47,000. So the convention is to say that our error interval starts at 46,500. Any number from 46,500 will round to 47,000 up to the point of 47,500, but excluding 47,500. So here we have where the number A could have been in the first place. I should put an uppercase A. Could have been in the first place. It could have been anywhere from 46,500 to 47,500. It has to be bigger than 46,500 or equal. So you can use the signs correctly. And then on the other side, A would have to be, your number would have been to be smaller than 47,500. And as we are using strictly smaller rather than less than or equal, then we are respecting the fact that 47,500 would round up. So 47,500 doesn't belong to the interval. It's the boundary, it's the limit, but it doesn't belong to the interval. And this is how we find the error interval. The lower value here is called the lower bound because it's the lower part of the interval, it's the lower boundary. So this is called the lower bound. And then the one on the upper side will be called the upper bound. Okay, so we have looked already at the number 47,000 rounded to two significant figures. We used the number line, and then from the number line we actually found the boundary, the limit of where the numbers could have been if they rounded to 47,000. So we would have had 46,500 and 47,500. Therefore, our error interval was from 46,500, including 46,500, all the way to 47,500, and we would write the error interval, if we use the letter A to represent 47,500, in this correct notation. So saying A will have greater or equals to 46,500, but A has to be less than 47,500. Now, how does that work if you have a smaller number? Just keep on taking the same approach. So help yourself from a number line. So the number we have is 47. You have two significant figures, which means that on your number line, the previous number would have been 46, and the next number would have been 48. So where are the limits of the numbers that would round to 47? Well, it would be right in the middle. So really your boundaries would be between 46 and 47 is 46.5. Between 47 and 48 would be 47.5. So we have our number would be greater or equal to 46.5, but it has to be less than 47.5. And in the third example here, now we have 4.7, still two significant figures. Continue using the help of a number line. So in that case, our number now will be 4.7, and the number before on the number line, if you have two significant figures, will be 4.6, and the one after will be 4.8. What are the limits of our error interval? It's right in the middle between 4.6 and 4.7, that would be 4.65, and between 4.7 and 4.8, which would be 4.75. So really our error interval, we're going to go from 4.65, and our number A has to be greater or equals to 4.65. Why equal? Because 4.65 would round up to 4.7. However, A has to be less than 4.75. It cannot be equals to 4.75 because otherwise 4.75 would round to 4.8. Okay, so on this slide, we're going to look at another 3 examples of finding error intervals after rounding, but this time the rounding changes. So the first example, we have 1 significant figures, then we have 2, and to finish with, we're going to have a number that has been rounded to the nearest 5. And for these questions, again, we're going to use the support of a number line to find the limits of rounding, so the limits of your interval. And on your number line, start by putting the number it's been rounded to, so you're told that we're working with 3,000. Because it's been rounded to 1 significant figure, then on your number line, every number must have 1 significant figure, which means after 3,000, the next number with 1 significant figure would be 4,000. And the one before would be 2,000. So your limits, when you have rounded, the smallest you could have, the smallest number that would round to 3,500 would actually be exactly in between 2,000 and 3,000. So that would be 2,500. And the biggest numbers, the limit of where numbers would have stopped rounding to 3,000, the boundary would be exactly in the middle as well, which would be 3,500. But this time we need to be careful because 3,500 would round up. So even though it's the boundary belongs to the next interval. So the way we're going to represent our number line here is to say that our number A, it has to be greater or equal to 2,500, but it has to be less than 3,500. Now the second example, we have to be a little bit careful here because we're still working with 3,000, but you're told this time that you have 2 significant figures. So 1, the 3 is the first significant figure, and then the following 0 is the second significant figure. So we're going to write 3,000 on our number line, but we need to keep in mind that the number line has got 2 significant figures, not just 1. So this means that the next number on the line that will have 2 significant figures will be 3,100. And the number before would therefore be 2,900. So what are the limits for your rounding? Well, the smallest number that would round to 3,000, between 2,900 and 3,000, would have been 2,950. So this number A, if it's been rounded to 3,000 to 2 significant figures, it could have been anything which is greater or equal to 2,950. However, the biggest number that it could have been, and actually that's the boundary that would start rounding up to 3,100, is also in the middle. So we have here 3,050. But A has to be strictly less than 3,050, because if it was equal to 3,050, it would round up. And then the third example here is, what are we going to do if it's rounded to the nearest 5? Well, you're still going to use a number line. You're going to put your 3,000 in the middle, but your number line now needs to go up in 5s. So this means that the next number would be 3,005, and the number before would be 2,995. And we do the same thing again here. We find the point where you start rounding to 3,000, and that point here would be 2,997.5. So all the numbers that are bigger than 2,997.5 or equal to 2,997.5 could round to A, which is 3,000, all the way to 3,002.5, but excluding 3,002, and 2.5. So it means that A has to be greater or equals to 2,997.5, but less than 3,002.5. And those are your error intervals. So what to remember from this is you have to be very careful and pay a lot of attention to how much is being rounded, because even though it looks like your number has got only one significant figure, well, it doesn't mean it's been rounded to one significant figure. So you really need to read this with attention, and then the number line is very helpful to find your upper bound and your lower bounds. On this final slide, we're going to look at the difference for the error interval of a number that's been rounded to one decimal place as opposed to truncated. So we're going to start by looking at the rounded, and we're going to use the same method. So we use a number line. We're going to place 34.6. It's been rounded to one decimal place, which means that your number lines needs to have one decimal place. So the next number will be 34.7, and the number before would be 34.5. So the limit of your error interval will be right in the middle, which means that on the lower side, on the lower bound, the number could be 34.55, and on the upper bound, on the upper side, it will be 34.65. So my number A can be greater or equals to 34.55, but less than 34.65. So that's what we have been looking at in the previous two slides. How is it different from truncated? Well, so let's put again, the number is going to be the same. We have got our 34.6 and 34.7 to the right, 34.5 to the left. And if you remember from the first slide, how does truncating mean? What does truncated mean? It means that everything that is afterwards has been rounded down. Truncating means you always round down. So if a number was lower, all of the point that's lower to 34.6 or 34.5, they would all round to 34.5. So if your number is 34.6 and it's been truncated, you know that it had to be bigger than 34.6 or equal to 34.6. If you have 34.6 in the first place, then truncating wouldn't make a difference. And all of the numbers, all of the way up to 34.6, 9999999, etc., would be truncated down to 34.6. The first number that would stop truncating to 34.6 would be 34.7. So we are again going to represent the interval by showing that the truncating will stop at 34.7. So your error interval, if you have truncated your number to 34.6, the lower bound is the actual number. So the lower bound is 34.6. And your number could have been anywhere all the way to 34.7, but excluding 34.7. So we are going to mark this error interval as A being greater or equals to 34.6, but strictly less than 34.7. The next slide gives you quite a bit more practice, which I strongly recommend you do before finishing this slide pack.